Alright, we're in the Pilot's Handbook of Aeronautical Knowledge. We'll be on a 2-10, fluid spills on composites. Some owners are concerned about fuel, oil, or hydraulic fluid spills on composite surfaces. These are generally not a problem with modern composites using epoxy resin. Usually if the spill doesn't attack the paint, it won't hurt the underlying composite. Some aircraft use fiberglass fuel tanks, for example, in which a fuel rides directly against the composite surface with no sealant being used. If the fiberglass structure is made with some of the more inexpensive types of polyester resin, there can be a problem when using auto gas with ethanol blend into the mixture. The more expensive types of polyester resin as well as epoxy resin can be used with auto gas as well as 100 octane aviation gas, avgas, and jet fuel. Lightning strike protection. Lightning strike protection is an important consideration in aircraft design. When an aircraft is hit by lightning, a very large amount of energy is delivered to the structure. Whether flying a light general aviation airplane or a large airliner, the basic principle of lightning strike protection is the same. For any size aircraft, the energy from the strike must be spread over a large surface area to lower the amps per square inch to a harmless level. If lightning strikes an aluminum airplane, the electrical energy naturally conducts easily through the aluminum structure. The challenge is to keep the energy out of the avionics, fuel systems, etc., until it can be safely conducted overboard. The outer skin of the aircraft is the path of least resistance. In a composite aircraft, fiberglass is an excellent electrical insulator, while carbon fiber conducts electricity, but not as easily as aluminum. Therefore, additional electrical conductivity needs to be added to the outside layer of the composite skin. This is done typically with fine metal meshes bonded to the skin surfaces. Aluminum and copper mesh are the two most common types, with aluminum used on fiberglass and copper on carbon fiber. Any structural repairs on lightning strike protection areas must also include the mesh as well as the underlying structure. For composite aircraft with internal radio antennas, there must be windows in the lightning strike mesh in the area of the antenna. Internal radio antennas may be found in fiberglass composites because fiberglass is transparent to radio frequency where a carbon fiber is not. The future of composites. In the decades since World War II, composites have earned an important role in aircraft structure design. Their design flexibility and corrosion resistance, as well as a high strength-to-weight ratios are possible, will undoubtedly continue to lead to more innovative aircraft designs in the future. From the Cirrus SR-20 to the Boeing 787, it is obvious that composites have found a home in aircraft construction and are here to stay. So we'll hold off right there. That was a 2-10 in the Pilot's Handbook of Aeronautical Knowledge. See you.